This is R.D. Sharma solution, class 12th, chapter 9, continuity. MCQ multiple choice questions we are taking. So this question, we have actually two solutions here. So whichever you want to follow, you can follow that. The concept is same in both of these solutions. Okay. One of them I am going to tell you, and second one I showed you. So basically, limit extends to a, which is actually 0 here, fx. So when you are taking x tends to 0, you will take, because it is not equal to 0, so you will take cos x raised 1 by x, it is equal to fa is 0, f is 0, which is equal to k. So the limit has to be equated to k. So cos x 1 by x, cos x raised to 1 by x. How are we going to solve this? Cos x 1 by x. So when we apply the limit, the one method is to take the log. The second method is to take the direct identity, direct relation. So cos x is fx and gx is 1 by x. So cos x, when you apply x is 0, it is tending to 0. Gx 1 by x, it is tending to infinity. So when you have 1 to infinity form, 1 raised to infinity form, then we have e to the power. See, this result you have to know when you have learned limit. So it is equal to e to the power, limit extends to 0, fx minus 1 multiplied by gx. Sometimes you may not be able to recall these, so then in that case you can use the logarithmic, the concept of logarithm. But if you remember this, you can apply this 1 to the infinity form, so you actually solve like this. Okay, now this becomes very easy now, because we'll be dealing with e later, that is fx minus 1, so cos x minus 1, and gx we have assumed it to be 1 by x, so it will be multiplied by 1 by x, so it will be in the denominator. Okay, let's have limit extends to 0, cos x minus 1 by 1. See, you can always write this is 1 minus 1 minus cos x, you can always write it as 2 sin square x by 2, you always have x. Then you can just have this x included, and you have to multiply the x with the numerator also. You can have 4 here, and then you have sin x by 2 by x by 2 whole square. Limit x tends to 0, sin x by 2 by x by 2 is 1. And then you have a x that you have introduced. So when you apply the limit, it will be 0, because there is an x. X tends to 0, x is equal to 0 is 0. So finally what you get is this value, total limit extends to 0, cos x minus 1 by x, this becomes 0. I hope you got the idea. This is going to be 0 because there is an x which we introduce, which is in the numerator, and that gives you 0. So this becomes 0. So now this is 0. E raised to the power 0 is what we have to equate, k. So it is equal to k. So e raised 0 is k. So what is 1? Anything to the power 0 is 1. So 1 is k. This is also one of the way you can just go through it, but the concept is same. Okay, this question we have already done in the VSAQ 9.2 exercise. Various exercises we have already discussed, and the concept is quite easy here. Since we have done, I'll just tell you how to solve this, because this is MCQ question. Modulus is always continuous. So mod x, if you assume it to be f, it is continuous. Mod x minus 1, if you assume it to be g, it is again continuous. When you add them, f plus g, it will be again continuous. So when it is continuous, fx is continuous at x equals to 0, x equals to 1, because mod x is all about when it becomes 0. So x is 0. X minus 1 is 0 when x is equal to 1. So at x equal to 0 and x equals to 1, it will be. So this is 0 and 1, 2 points. And the answer is that fx is continuous at both these points. You can also, how to do this, I'll just give you an idea. 0 minus h, 0 plus h, you have to find out the left hand limit, right hand limit at 0. Same at 1, because 1 plus h, 1 minus h, for left hand limit, right hand limit, you have to equate it, and you will find out. I can tell you, because we have already done this type of question, so I can tell you that it will be continuous. We have already showed it to be continuous, right? For example, when you really want to find out the value of the function at 1 and 0, so you can just put this value, and that will be equivalent to the value of left hand limit and right hand limit in the case of 1, in the case of 0. So we can just tell that fx is continuous at x equals to 0 and x is equal to 1, right? Now fx is given like this: when x is not equal to 1 and 2, when x is equal to 1 it is 6, x is equal to 2 it is 12. So if then fx is continuous on the set, right? Now you have to concentrate on the first, because you have to check at 1 and 2. So the value is exactly at 6. At 1 is 6, at 2 it is 12. So you have to find out the left hand limit and right hand limit at 6. LHL and RHL at 12. So we will first resolve this what is given, and this will take an effort. Please understand it very carefully. Mod x minus 1 into x minus 2. You can separate them also, mod x minus 1 and mod x minus 2. It doesn't matter. X square minus 5x square plus 4. So we have to find out the factors of this. So x raised 4 and this 4, so you have 4, so you can write it as minus x square minus 4x square. That will eventually be equal to minus 5x square plus 4. You can take x square common, so you have x square minus 1. You can take minus 4 common, you have x square minus 1. So eventually you get x square minus 4 and x square plus x square minus 1. So you have x minus, it can be assumed to be 2 square, x square minus 2 square. So basically what are you going to get? X minus 2, x plus 2. So this is basically a minus b, a plus b, x square minus 2 square, a minus b, a plus b, x minus 2 into x plus 2. In x square minus 1 square, it will be x minus 1, x plus 1. Again, a square minus b square formula we are using. Right. So this will be in the numerator. X minus 2, x plus 2, x minus 1, x plus 1. Right. Now you have to be very careful about where this value x minus 1 into x minus 2 or x minus 1 separately and x minus 2 separately, they are going to be equal to negative or positive. So when you go on the left of 1, what will be the value? Mod x minus 1. See, 1 is the deciding point for x minus 1. Above 1, x minus 1 will be positive. Below 1, x minus 1 will be negative. Right? Similarly, x minus 2, x equals 2 is the deciding point. X greater than 2 is going to be positive. X less than 2, it is going to be negative. Right? So we are talking about x less than 1 now. Let us see. I hope you got the idea. At x below 1, it is going to be negative x minus 1. When it is x minus 2 less than 1, as I said, x equals 2 is the deciding point for x minus 2. So you are going on the left of x minus 2. So will it be positive or negative? What do you think? It has to be negative because 2 is the deciding point. You go left, it will be negative. You go right, it will be positive. And what is the numerator? X plus 2, x minus 2, x plus 1, x minus 1 and x plus 2, x minus 2. Now you can cancel these two. Only the thing will remain is x plus 1 and x plus 2 when x is less than 1. This is for x less than 1. Now you have to check for x greater than 2 also. And you have to check for x in between 1 and 2 also. So what I am doing here is x minus 1, x minus 2. I am writing it again just in case you miss something. So just cancel these two. And x plus 2 and x plus 1. Only positive, that is plus values will remain. But it will be negative in the denominator becomes positive. So first let us do the x greater than 2. Then we will talk about 1 and 2 in between. So x is greater than 2 we are talking about. It is not 0. I have written it. I'll just correct it. So when we are talking about x greater than 2. So again, 1 is the deciding point for x equals x minus 1. 2 is the deciding point for x minus 2. When you are going above 2, both will be positive. When you remove the modulus sign, both will be positive. So you just cancel these out is the same way and you will get x plus 1 and x plus 2. Now what about 1 and 2? So when you are between 1 and 2, what is the deciding point for x minus 1? So you are above 1, so x minus 1 will be positive. But you are below 2, so x minus 2 will be negative. that is x minus 1 and x minus 2. 1 is the deciding point for positive and negative for x minus 1. 2 is the deciding point for x minus 2. So you get x plus 1 and x minus 2. X minus 2 will be negative. So there will be negative. So you see there is a negative for x which is in between 1 and 2. Okay, let me just reiterate. We solve this. Then we try to find out what will happen for to the modulus and to the expression consequently for x less than 1, between 1 and 2, and then x is greater than 2. Okay. So this we have done. Now let us come to the exact point 1 and 2. So we will take the left hand limit for 1, right hand limit for 1. Similarly, we'll do it for 2. I hope you'll be able to do it for 2. I'll just concentrate on this 1. So this is exactly same what we'll do it for 2. 1 minus h. So just put, because when you are going on the left of 1, that is x less than 1, so you will use x plus 1 into x plus 2. So I'm replacing x by 1 minus h. So 1 minus h plus 1 and 1 minus h plus 2. This is when you're going to x equals 1 minus h. So you get 2 minus h, here 3 minus h. Now apply the limit. So this will be, you have to write, replace x as 1 minus h, which we already done. Now you get 6. 3 into 2 is 6. Now in between 1 and 2. 1 and 2. So as I said, when you go above 1 and 2, you have to use. So 1 plus h you have to keep in minus x plus 1 into x plus 2. Again, just replace x by 1 plus h. So you get 1 plus h plus 1, 1 plus h plus 2. So 2 plus h you get, and 3 plus h you get. Negative will be there. Now, so you get minus 6, negative 6 here. So 6 and negative 6 are not equal. So left hand limit and right hand limit, they are not equal. So you can very well say that in this case, the values are not matching. So the function is not continuous at 1. Same thing you have to do for 2. X equal 2. Please remember, left hand limit you have to write 2 minus h. Right hand limit you have to write 2 plus h. One time it will come as 12. One time it will come as negative 12. Because when you go on the left hand limit, left hand side, it will be negative 12. Let me just do it. Because when you go on the left hand side of 2, you have to use negative x plus 1 into x plus 2, where in the place of x you are going to replace x by 2 minus h. 2 minus h I am replacing 2 minus h plus 1, 2 minus h plus 2, and this will be negative. Please remember, it is negative. So you just replace this, h will be 0. So 3 into 4, this is 12. You have a negative here, so negative 12. Now 2 plus h, then you go up. So 2 plus h plus 1 and 2 plus h plus 2. Again, replace h by 0. It will be positive because it is greater than 2, and we have to use x plus 1 into x plus 2, where we replace x by 2 plus h. So you have this as 4 plus h. Just replace h by 0. You get 4 is a 12. So you have negative 12 and 12. These are not equal. So it is not at 1, not at 2, not continuous. So just you can write that the point of discontinuity is real number except 1 and 2. Next one is quite clear. It is x less than 0, x greater than 0. So you have two expressions for less than 0 and greater than 0. And when x is equal to 0, you already have c. So left hand limit, right hand limit you have to find out, and you have to equate it with f0. f0 is what? C. So you will get a and b and c, but you will see that you will not get a value of b. You will just see. A and c you will get. For getting b, you have to apply a different tactic. So at 0, left hand side you have to write 0 minus h. For x, at above 0 you have to write 0 plus h, right? So negative h and h you have to use. So x less than 0, we have to put negative h here, because you are going on the left hand side of 0. Sign a plus 1 into, in place of h, just replace it by negative h. Plus, because 0 minus h is minus h only. Sign minus h. And divided by x is, this is minus h. Okay. So this sine negative theta is minus sine theta. Sine minus theta is minus sine theta. This is going to be minus sine a plus 1 into h, and then you have negative sine h divided by negative h. Now you can take negative outside from here. Sine a plus 1h will be there, and plus sine h, and you have a negative h in the denominator. So minus you can get cancelled, and h I am taking in the denominator and separating in this step only. Now apply limit h tends to 0. So you know that sine theta by theta limit theta tends to 0 is 1. So you can have a plus 1 in the denominator, a plus 1 in the numerator. I am just introducing it. As I said earlier, sine theta by theta is equal to 1. Now this whole will be 1, a plus 1 will remain. Here sine h by h, it is going to be 1, so 1 will remain, so a plus 2 you will get for the left hand limit. Coming to the right hand limit. Now for the right hand limit, it will be, see here, I am just changing the color so that you understand we are doing it for x greater than 0. So for x you have to put 0 plus h. So it is h, 0 plus h is h only, so replace this x by h. H plus bh square minus under root h divided by bh under root h. Now just take the under root h common. So you can write this root h in this root h. So what I am trying to suggest here is root h. You can take h common inside first. H 1 plus bh whole square. When you take h common, it will be only 1 plus bh. Now this can be written as under root h into under root 1 plus bh. So this root h and root h I am taking common. Why I am taking common? Common because root h is in the denominator. So root h we have taken common, 1 under root 1 plus bh minus 1 will be remain. And in the denominator you have bh into root h. So you can just cancel this root h and root h out. Now this we have to rationalize. So a minus b is there, so a plus b you have to multiply. So in this case, you have to multiply it by under root 1 plus bh plus 1. Here also under root 1 plus bh plus 1. So this is a plus b, this is a minus b. So a square minus b square it will be 1 plus bh minus 1. And in the denominator we have under root 1 plus bh plus 1. So we have bh already here, bh, and then we have under root 1 plus bh plus 1. So this gets cancelled, bh because 1 minus 1 is 0, bh gets cancelled. We are in the denominator under root 1 plus bh plus 1. So limit h tends to 0. We have 1 by under root. So this is going to be 0. Under root 1 is 1. So 1 plus 1. So 1 by 2 you get. Okay. Now a plus 2 is equal to half. From left hand limit you got a plus 2. Right hand limit you got 1 by 2. So a plus 2 is equal to 2. A is equal to half minus 2. So 1 minus 4 by 2, that is going to be minus 3 by 2. So what do you get? A is minus 3 by 2. You see in the options, all the first 3 options have minus 3 by 2. So you have to think about C now. C is half. So first and third option becomes quite clear. The answer has to be equal to 1 and third. So C is half, C is half, and A is negative 3 by 2. So what about B now? What to do with B? So we cannot directly get the value of B here. So for that, you have to see what is the scenario for this expression when you are talking about any expression which has b. So we have under root 1 plus bx minus 1 by bx. So we have to come here again. Okay. So this first and third we are checking which one is correct. This is x plus bx square minus under root x and divided by bx under root x. So under root x into, we have already done with h. I am just repeating it again. So 1 plus bx, it will be 1 plus under root bx minus 1, bx cancel, under root x will be there. So 1 plus bx minus 1 divided by bx. Now when this will exist, when the denominator cannot be 0. Bx should not be equal to 0. When it should not be 0, we are not talking about x, we are talking about b. B cannot be equal to 0. So that this expression will be only valid when b is not equal to 0. So b is not equal to 0, that is b belongs to all the real number except 0. You can have all the value in the world except 0. So this is b. A is minus 3 by 2, B is real number minus 0, and C is 1 by 2. So third option is correct. This is your answer. Okay, this question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.